In the first video, we started looking at terminology involving circles, arc length, and area of a sector. We're going to continue on with our study of circles in this video. We're going to start by looking at the area of a segment of a circle. You're probably wondering what's so different between a sector of a circle and a segment of a circle. So let's take a look at that. Previously, we had said that a sector was this piece that was in here, bounded by the radii that connect to the center of the circle and the two endpoints of the arc. Well, a segment is part of a circle bounded by an arc and the segment connecting the endpoints of the arc. So in this arc AB right here, we would have arc AB, and then we would have a segment connecting from A to B. And in here, this right here would be segment AB. Let's try this again. Let's make it a little bit neater. So this in here would be segment AB. So we have to look at how we would find the area of that segment. You may have already started thinking that the area of a sector minus the area of a triangle is going to equal the area of the segment, and you would be correct. So let's take a look at this. So if we look at example 1, we see that we're trying to find the area of segment AB, and we're given some information about angle AOB and arc AB. So the first thing we have to do is find the area of the sector. So area, sector, AOB. So if you remember correctly, that is our portion of our arc, so 90 degrees over 360, times the area of the circle, which is pi, and our radius is 10 inches. So pi r squared. Okay, so we're going to find out what that is. Well, I know that 90 goes into 364 times, so it's 1/4 times 100 pi inches squared. And I know that 1/4 of 100 is 25, so 25 pi inches squared. Remember, units are incredibly important, and don't multiply by pi unless you are told to. Leave everything in terms of pi. Okay, so the second thing that we have to do is find the area of triangle AOB. Well, life is easy for us this time because it's a right triangle, so we know the area of the, we know the length of the base and the height are just the lengths of the legs, which are, in this case, both 10 because they're both formed by radii. So 1/2 of 10 times 10, which is 50 inches squared. And now we have to find the area of the segment is going to be the area of the entire sector, because remember, it's the big portion. So 25 pi, oops, 25 pi, not 2 pi, 25 pi minus 50 inches squared. You might remember from other classes that the probability of an event happening, whether it was tossing a coin and getting heads or tails, or maybe rolling a die and getting a number that you were looking for, is what you want, which we call the favorable outcome over the total possible outcomes. And we can apply the same thing with geometry. So if I wanted to look at the possibility that if I dropped something, it would land between the 2-inch mark and the 5-inch mark on this ruler, I would look at how many there things there are, how long it is. And so there's 3 inches. So the probability between 2 and 5 would be 3 out of a total of 1, 2, 3, 4, 5, 6, 7, 8. So there's 3/8 of a chance that it would land in the length of the segment that I was looking at. So this is the length of the segment that I want over the total length. So here we have a dartboard that is 1 foot by 1 foot square, so 12 inches by 12 inches. And inside it we have some circles, so it looks kind of like a dartboard. And we want to find the probability that we would hit each one of these regions. Now I'm going to give you a little more information. These 3 concentric circles, concentric means they all share a center, have radii of 1, 2, and 3 inches respectively. So that means the blue circle has a radius of 1 inch, the yellow has 2 inches, and then the red has 3 inches. I'm going to clean this up just so it doesn't look so messy. So the blue has the smallest, and each one is 1 inch bigger. Okay, so the first thing we have to do is find the probability that we would land inside the blue region. Well, this one's easy, so probability of blue. This one's going to be the easiest. It's going to be the area of the blue region over the area of the total dartboard, so total area. And since this is the total area of the dartboard is the square itself, we're going to replace this. Instead of talking about the total area, we're going to say that it's the area of the square, because that is the maximum area possible, unless you hit the wall. Okay. So the first thing we would have to do would be to find the area of the blue circle. So I know that the area of a circle is pi times radius squared. And in this case, our radius is 1. And our square is 12 inches times 12 inches because it is a square. So for us, that is pi over 144. And since it's inches squared divided by inches squared, we end up with pi over 144. Now if you take out your calculator, that's approximately equal to 2.2% chance of landing within that little blue circle. Now let's find the probability of landing in the yellow region. So that's going to be the area that's yellow over the area of the square. But what makes this one a little bit tricky? Take a moment, pause the video, and see if you can figure out what would make this a little bit tricky. If you came up with the fact that the area of the yellow region is not the total area within that yellow circle, so if you said that the area that's within the yellow circle but can't include the blue, then you are correct. Okay, so let's erase that. So we can't include that blue section, so we're going to have to subtract it from our total area of that circle. So let's find the area of the yellow circle first. So just like before, it's pi. This time our radius is 2 inches squared. And we have to subtract off that area of the blue, which I know was just pi inches squared. So we end up with 4 pi minus pi. I get 3 pi inches squared over 144 inches squared. And yes, we can just keep saying 144 for our area of our square because it hasn't changed. So let's say, if I can simplify that, no, I don't think I can. Okay, oops, 3 pi over 144, which is going to be approximately 6.5% chance that we're going to get in that yellow region. So we're getting better. We have a better chance. Now let's continue on and do the same thing for the red. So the probability of the red, we don't have to start from the very beginning because we already know that it's going to be, it's going to be area of red over the area of the square. What I mean, we don't have to start from the very beginning. We know the area of the yellow includes the area of the blue. So I get 3 inches squared times pi minus 4 pi inches squared over 144 inches squared, which leaves us with 5 pi, 9 minus 4 is 5, over 144, which is approximately 10.9% chance of getting it within that red region. As you can see, as you get into a bigger and bigger circle, you have a better and better chance of getting your dart into that region. Your homework for this video is a worksheet, and the extra copies, if you lose yours or if you weren't in class, is posted on the class website.